to have loaded. Okay, I just hope that it doesn't happen again. Let me scroll. Okay, it looks like it's
It,
scrolling
it
now.
is
Okay,
scrolling now.
okay, and then don't feel free to unmute yourself and talk to me. You don't have to, just ask questions. Don't worry about uh, uh, don't worry about asking questions. Okay,
Well, I
okay.
think the
So
problem is that John jinxed you.
no, I don't think so. He said he's. I don't think so. Anyway, so let me restart. Basically, this course I've never taught before, so I'm going to try to teach this class, develop my notes, but some parts of this is taken from the Legate Robotics class. Sorry, the robotics class which I taught last semester, which I've been teaching for 5 years now. Uh, the link is given here for that so that you can remember. It's really short. We require a computer, which is obvious, but it also requires 4 GB RAM, 8 GB preferred. That's for MATLAB. I highly recommend that you have a MATLAB copy on your computer. Okay, don't use the Citrix version. And fortunately, it's available for free. Ernesto gave the suggestion, so that link I've put in the syllabus. I hope you know where to find the syllabus. If you go to, I think it's tiny.cc Lec1a. Yeah, then you go to my Dropbox folder, and then you can find the syllabus. So tiny.cc Legate, that's the shortened link. Okay, let me just paste that in the chat bar. Okay, and then the other link is tiny.cc Legate vid. I forget the link. Hold on. It should be on the syllabus, so we should find it here. Yeah, so leg videos, that's the other link which I'll paste in the chat bar. So if you click on that link, it'll take you to videos, which are basically, it's a playlist. So there are just two links, well, three links you need to know in this, need to remember. One is the Zoom link, which is tiny.cc robotics Zoom, which gets you to this Zoom link. Then there is the tiny.cc Legate, which gets you to notes, homework, syllabus, and the third one is the playlist on YouTube. Okay, let's jump back. Okay, now what I did was I basically decided to separate this into tools which you need to learn in order to analyze Legate systems, and those are mentioned here. And then, and by the way, those tools are applicable to other systems, not just Legate robots. So I thought I'll separate it out. And then what we'll do is we'll really take an approach where we are understanding these tools with examples. So I like to start with double pendulum, which is two links, and then show how that double pendulum can be used to create a legged robot walking downhill. And then if a spring mass damper is a hopping robot, and then we'll go to more complicated versions. And my goal is to come to this point where you are designing the system in MATLAB, okay, and then you're verifying it on Coppelia Sim. So Coppelia Sim is sort of like a black box simulator where you do not see the physics, so you don't know what assumptions they make in modeling the system. But when you try something in MATLAB and then transfer it on Coppelia Sim, that's going to tell you loopholes in your controller design, and that will help you to tune your controller. And really, this is sort of simulating real world. Coppelia Sim is like the real world. It's not in hardware, but it's in software. But it has its own modeling assumptions which you don't know about when you developing the controller. So I would like to get to this point where all of you are doing some amount of verification on Coppelia Sim and improving your controller based on what you see in Coppelia Sim. What I decided to do, and I think this is beneficial for all, is to have weekly homework, and this is going to be like maybe 1 or 2 questions. And the purpose of the homework is, it's not like I'm judging you or anything like that. I just feel that if you sit in the class, you listen to lectures, and you don't apply what I teach you, then you're going to forget things. You are not going to know how to apply things. I can just have a project towards the end, but then the build up towards the project is going to be like, there'll be holes. So for example, I do inverse kinematics, I do dynamics, and so on. So if I just keep teaching things and then wait till the end, then I think you'll not be able to reap the full benefit of me teaching it the way I've set it up. So the homeworks are supposed to help you or sort of force you to go back to the what I've been teaching, the lecture notes, the videos, and sort of think on how you can apply what I've taught in a new problem, which will be very similar to the problem I'm teaching in the class. So it's going to be, I think it's going to be fairly straightforward. The way this will help you is that will force you to read through the notes and do calculations. And I don't think this will take more than 5 hours of your time. It's probably going to be much less than 5 hours. And then we'll have a final project, and this will be basically something which each of you do individually. And by the way, for the homework, you can talk with each other and discuss and so on. For the final project, what I'm trying to do is hopefully that project will launch you into a research topic, and so you can then be independent and then take that final project and then maybe make it into your research project or explore things so which will then become your research project. So that is basically the most attractive part, is it hopefully will lead to a research project for all three of you. What I found is there's unfortunately no good textbook. However, if you want to see a reference, then you want to go to this website. It's a professor from MIT. He has a course on underactuated robotics, and legged robots are one example of underactuated robotics. So he has other things, other systems which are underactuated, and legged robotics is different than those systems in many ways. But I think it's a good reference. All the links are here, which I just dropped in the chat icon. And then, as I said, the assessment is important because I want you to apply what I teach you in the lectures, and then once you apply that, then hopefully it will build onto a project which will then set up your research agenda. Okay, so I'll stop here. If you have any questions,